Hello and welcome to this episode of Math with Martinez. We are in our 7th unit in Algebra 2, where we're looking at cubic and cube root functions and equations. And today, in this video, we are looking how to verify inverses using composition. In our last video, we saw that there's this relationship between two functions that are inverses. If they're inverses, they're going to be reflecting across this line y equals x. Or another way of saying that might be to see that their points, the inputs and outputs, or I could say the domain and range, they switch or they reverse with one another, like we noted here in our margin. But there's another property that I want to introduce to you guys about inverse functions, and that is related to this idea of composition. So here in this little graphic, we're illustrating function composition, where the output of our g function becomes the input of our f function. See, here's the thing. A cubic function and a cube root function, like f and g here, will be inverses of one another, meaning that one undoes the operation of the other function. What do I mean by that? That sounds kind of crazy and like really advanced math, but let me illustrate it here with these little diagrams. Let's take something and allow it to be going into this function machine. Let's take a number, something small, something easy to calculate. Let's do 2. If we take 2 and plug it into our g function, what that means is going to happen is we're going to take and replace x with 2. And so what happens when you take 2 and cube it? The output of that is 8. So it went into the machine. The rule was applied to it, this being our rule that we're going to take our input and cube it, and what comes out is 8. Now, that is going into and being applied to the rule of our f function, which is a cube root function. And we know that these two functions right here are the parent functions and are inverses of each other. And so when we have these inverse functions, what's going to happen here, check this out. When we take and allow 8 to be applied inside of the rule of our second function machine, we're taking the cube root of 8, and the cube root of 8 is 2. So what just happened? What was originally the input when this system was applied to it, and this system is of functions that are inverses of one another, the original input is the output after the system has been run. Composition of functions, what we just modeled with these little machines, is the process of substituting one function into another function to create a new function such that the range or the output, like we saw right here, the range, the outputs of the first function become the inputs of the second function, or the domain is what we call that. And with composition, we're able to verify that functions are inverses, because here's the big idea. Two functions, f and g, like we saw up here, are inverses of one another if and only if f of g of x, which is the same thing, that notation is the same thing as saying take f and plug into it g of x, gives us x, meaning the original input is now the output. And so not only that, but that has to be true, but also the other way around. G of f of x, which is the same thing as saying g of f of x is x. So no matter which way you compose it, no matter which function you plug into the other, when you do that, those two functions are going to have whatever you plug in at the very start will be the output at the very end. And I've illustrated that here in this little diagram. So check this out with me. In this first diagram, we're taking and plugging 10 into the inverse function. When you take 10 and plug it in right here, it would be 1/2 times 10, which is 5, and then you subtract 2, and the output is 3. Now if we take 3 and plug it into the original function f, then what does that give us? 3 times the 2. 3 times 2 is going to be 6, and then you add 4 to that, and our output is 10. So what we did is we took 10 inside of the inverse function, so 10 is inside of my inverse function, and then the result of that, which is 3, was plugged into f, and the output was 10. So what we wanted, original input matches the final output. These two functions are inverses. And it works the other way around. If you first plug 10 into the original function f, you take 2 times 10, that's going to be 20, and add 4 to it, 24. So right here, this is 24. Now take 24 and plug it into the inverse function. 1/2 of 24, that's going to be 12. Subtract 2 from it, and it's 10. So we've got it. We've got the original input matching the output after we do this system, after we do this process where we are composing our functions or taking and allowing the range, the output of one function to be the input of the next. So they have undone each other. So let's go ahead and determine whether the pair of functions right here, f and g, are inverses of one another. What I like to do here is I like to do a little highlighting. We're going to let our f function be blue and our g function be green, just to help us when we're working with these two machines, you could think of them, so that you remember which one is which. So let's go ahead and get started here. We're going to compose, like it says, first f of g of x. Now f of g, the way I'm reading that, don't read it as fog, it's f of g. It can be written like that, or better written, f of g of x. And so what this is notice what we've got going on. What is inside? The inside function is g. The g function is inside of the f function. So let's go ahead and see what that would look like. What does that look like? That means let's take our f function and plug in the rule for g, which is x minus 3 cubed plus 1. That is my green function being plugged into my f function. It's going to be the input of f. So what that looks like here is I'm going to take this rule and plug it here inside of my f function right there. Instead of just taking f of x, I'm going to take f of this entire rule. Here's what that ends up looking like. What is the f function? It is to take the cube root of my input, subtract 1 from it, and then after that, add 3. Now, what goes on that inside right there? That's going to be my x minus 3 cubed plus 1. So that, what I plugged into my blue function in place of the x, in place of that x is that green functions rule. So now let's start to simplify this, which I know you guys are masters at. We've been doing this a lot. So I'm looking inside that group. What can I do inside of that group? I'm noticing actually here that what I have, I've got this quantity cubed, and then I'm adding 1 and subtracting 1. And then outside that, I'm adding 3. Now, if I'm adding and subtracting 1 at the end inside of here, those are actually going to cancel each other out. And so what will we have? We will have the cube root of the quantity x minus 3, that's cubed, and then we're going to add 3 to it. Well, look at there. I am cube rooting a group that is cubed. So that's going to cancel each other out. Those are opposite operations, inverse operations. So they undo each other. So what's left was just what was inside of that radical, which is x minus 3. And then I'm adding 3 to that. Well, y'all, if I'm subtracting 3 and adding 3, opposite operations. And so what is left? Just x. That was what we were trying to get. Remember, if they're inverses, when you do your composition, when you take f of g of x, you should just get out x as your final output. So far, it's looking good. Now let's try to compose this the other way around as well. So what that means this time what we're doing instead is I'm going to take my blue function. I'm going to take all of this and I'm going to plug it in to my g function in place of its input. F is going to go inside of g. Let's write this down. We have g of f of x. So that f function, my blue function, is what is inside. It's inside of the g. So what is that f function's rule? The f function is the cube root of x minus 1 plus 3. All right. So now let's take that, like we demonstrated up here, let's take all of this and plug it into the g function as the input. So what does that look like? Well, I take this quantity, and that's going to be parenthesis. So I'm looking at my green function, and then it's the x value, but in place of just x, I'm going to write my whole blue rule that I highlighted above. And then what comes after that? Minus 3. Close it off, cube it, add 1. See, this is what I replaced the x from my green function with my entire blue rule. Now let's start doing our simplification and seeing what we get. I've got plus 3 minus 3 inside that group. That will simplify. Now I've got the cube root of x minus 1 cubed plus 1. Well, I'm cubing a cube root. Inverse operations right there. That will leave us with just the expression inside of that radical, which is x minus 1. And on the outside, we still have our plus 1. Minus 1 plus 1. Again, those are additive inverses, so they zero out. It leaves us with just x. So there we have it. Each time when we compose this, when we took f of g or g of f, the output was x. Therefore, we can say these functions are inverses. There we go. So that was one example. We're going to do one more in this video. Let's go ahead and start by highlighting our two functions. It really, I think, helps a lot to see this visually. So we've got our f function, we've got our green function, our g function, and we're going to first begin by composing it as f of g. So that is to take and plug g inside of f. So that looks like taking my whole green function, all of this, and it's going to go inside my f function where the x is. I'm going to replace that there. So that looks like instead of just f of x, I'm going to take the whole expression that is my g rule. Okay, so now let's go ahead and do that. My f function is 2 cube root of the input, but in place of that input of just x, I'm going to take and plug in my whole green rule there, which is 2x cubed minus 1, and then the plus 1 from the blue rule. Still there. Okay. Let's see how we can simplify. And if it simplifies to just x. Okay, looking good so far. I've got a minus 1 and a plus 1 right here. That's going to zero out. So we have okay, there we go. Now I'm taking the cube root of 2x cubed. Okay, now, ladies and gentlemen, what this really means is I'm taking the cube root of 2 and of x cubed. Now, the cube root of x cubed does cancel out, but the cube root of 2 is not a nice integer value. There's nothing that there's not a nice integer number that I multiply 3 times and get 2. So I actually can't simplify that part. So what I'm left with is this. Yikes. This part right here, these two things, they are not opposite operations. It would have worked if I would have had 1/2, but this does not simplify to 1/2. So we're going to go ahead and stop because this is not like the one we saw above. What does this mean? We didn't do anything wrong. All this means is that these two functions are actually not inverses of one another. So let's make that note. We don't have to keep going. We don't have to try this other composition, g of f. We stopped because we already came to a point where we recognize these functions are not inverse functions. All right, ladies and gentlemen, so there you see, that is how we verify functions are inverses using composition. If they are inverses, then when you do the composition, what you originally plug in to one function, that output, that range, when plugged into the second function, should match what you plugged in to start with. But if you get to a point where what you plugged in, which in our case was x, is not what you get out, then these functions are not inverses of each other. That's it for this video on verifying inverses using composition. If you have any questions, would you please take a moment and share those now? And until next time, stay fired up, you guys.